Welcome to our second to last video on the DMX series for DMX lighting. This is a quick video and it is going to cover how to program a RGB controller. Specifically, this is one of Holiday Coro's alpha picks as my example, but a lot of them program the same way. This is a smart controller. And just to review the setup here, we have our computer connected to our network at home. Our home network also connects to the controller. I'm going to show you how to figure out how to talk to this. We're going to use a web browser in this computer and browse this device and configure it for outputs so it knows what's on each output and how many pixels there are. We're going to also show you one that has a DMX channel off of here for a dumb controller. So let's get started, shall we? First things first, I'm going to show you that when you plug in a controller, most of them use dynamic addressing. So if you recall, actually we had it up here, this process, when you attach something like a PC, whether it's wired or wireless, the router at home or a server at work will give you an address using something called DHCP, Dynamic Host Configuration Protocol. And then you'll get an address and stuff like that. Now that's great for getting connected to your network and getting your DMX controllers connected, but being dynamic, that means it doesn't last forever and you have to ask for another one after a certain period called the lease time. So if the lease is 1 day, you get to use that number for a day, then you got to ask to keep it. And you might not be able to keep it. You might get changed to another one. So we don't want things like DMX controllers changing their IP addresses because our software is going to be programmed to look for that address. So if this was dynamic and it's 192.168.1.50 right now, and I program my software to talk to 50 for universes 1, 2, 3, and 4, and tomorrow it changes to .60, well, my software's not going to work anymore. My lights aren't going to go on. So we want to statically configure these. The key is when you plug them in, they're going to be dynamic. We're going to be able to tell what their IP address is. We're going to browse them, and then we're going to change it to static. So you start out dynamic, then you change them to static. Let's show you how to do that. Basically, you would connect a controller into your network. You'd have to wire it in. Let me pop over here to a screenshot. Then a lot of controllers have an LED panel, LCD panel right here. And when you plug it into the network, it kind of rolls through a couple, like 3 or 4 screens, and one of those screens has your address of this controller that it was given. So let's say that the IP address that comes up and shows here is 192.168.1.50. I can then go into a browser, type that in up here, and I'll get the screen of that controller. Now mine are already set, so we're just going to simply go to one of mine. I'm going to go to, let's go to tree 1. And you'll get a screen like this. You have to know what the login is. I already have mine set, so I'm going to log into mine, but you would log in with a generic password, and you get a very minimalistic screen like this. Okay? On this screen, you can change the passwords if you want, but mainly in the IP address section, this will be set to DHCP. We're going to switch it to static, and you type in a static number that is not being given out by your DHCP router. So if you're not sure, just make the last number here 200, then 201 for your next controller, then 202. In the high numbers, you're probably likely not to run into a problem. You also give it the subnet mask to match. Most of them will look like this, but again, I gave you instructions in the Ethernet addressing about how to find out what the subnet mask is. There's no default gateway because these things typically are not going to route on a lot of these. If there is a default gateway, you can give it one. And if you get a prompt for a DNS server, you really don't need one of those either. These devices don't really use that for much. So you would actually change those settings and then save it. The minute you change the settings here and apply it, this is no longer going to work. You're going to have to change this to the new number that you just gave it, okay? Because you're going to get disconnected and it changes its address. So then you change it to the new number, and if it's static, you might want to write it on the inside of the controller box or whatever so you know what it is. Or like I do, I make, let me see if I have this here. Let me open it. I made a map. I made a map of my network, my 3 trees, what IP address each controller's been assigned, what universes they have, how many pixels on each. Here's my house controller. running the lower roof and the upper roof on different outputs 1 and 2. And then it has this DMX RJ45 connection to the dumb controller, which runs 4 different outputs of 2 RGB floods each. So you might want to make a little diagram or something like that so you know, and then you save it. When you unplug these things, they will not forget these settings. So the next year you go to do your light display, they'll have the same settings again. So that's why you might want to write it down. A couple other things you can configure under here. The DMX input signal protocol. Now this, if you recall, let me jump back to here. The very basics, when we talked about DMX comes out of the controller to the lights. The controller talks over the network by putting the software puts DMX commands inside an Ethernet packet and sends it over to the controller, and that technology is called E131. So this setting in this section, and again, I'm only showing you one vendor's controller. They're all going to be a little different, but hopefully it helps. The input signal for the DMX protocol over the Ethernet is almost always going to be E131, which is streaming ACN, which stands for streaming, and I can't remember what the A stands for, control network. ArcNet is an old network technology. I haven't seen this in years, probably decades, so you're probably not going to use that, but most of your Ethernet protocol is going to be E131. Another thing to consider is when you buy RGB pixels and strips, whether they're dumb or smart, they don't necessarily always have the number. The first number is red, the second number is green, the third number is blue. Sometimes they're different. This is a BGR is another option here. So be aware of what you're buying and that the controller you have supports that order. RGB is the most common. This is not that setting. This is your controller software. So this one is mapping controller colors. Then down here lower, where is that other setting? The chip output, pixel chip output. So this section, I apologize, is from the application. So let me jump back to that screen. Let's go back to here. The software that's going to send stuff across the E131, is it sending it and is it mapped in this order, RGB or BGR? And that's a software setting. Most software is going to do RGB. So you might want to know that setting. On the flip side, here, the output to the DMX, to the lights, when you buy the lights, as I mentioned previously, you can buy different chip orders. So I have a whole bunch. You got RGB, RBG, GRB. Now, mine are set to GRB because the last order I ordered 24 of these reels, they came GRB. And the vendor contacted me and told me that, are you sure you want these? They're GRBs. And I said, yes, send them. I just map them to something else. The one vendor I use for these strips, I wasn't too happy when one year I ordered the RGB and the next year I told them to reorder the same thing, and I got the GRBs. So they switched the red and the green. And the way I knew that was I had this candy cane display, which were red and white stripes on the tree. When I wired in the new lights, all the new lights, it was green and white. All the regular ones originally I had were red and white, and then I contacted them and said, oh yeah, those are GRBs, not RGBs. So I can map the entire output of this controller, meaning on the DMX side down here, to one or the other, or I can map individual, if I go in advanced, I'm not going to do that. You go in advanced, you hit set, you can map every output differently. So when you look at the controller, I can map each one of these outputs to different orders if I had to. The only thing you can't do is I can't put a GBR here and an RBG here, RGB here. I can't mix them on the same output. So I kind of complained a little bit to the vendor, and he kind of just brushed me off. So I just made sure next year I ordered, and I knew what I was ordering, and I made sure they're all the same. And then I will just always double check that. Other things on this are the SPI outputs. Now, remind you what the SPI is. These little outputs are the SPIs. I thought I had 8-port outputs out there. I think I only have 4-port outputs. So they have 1, 2, 3, 4 of these on there. This is a 16-port output, so a bigger controller. And you can see here that the Outputs are listed. And just like we talked about in DMX addressing, you tell it what starting universe it owns and the starting channel, and then the number of pixels. And it knows, this particular controller knows you can't use 511 and 512, or maybe it uses them and I don't know, it's doing something different, but I thought it was not using those. And when it gets to 510, it just starts on universe 2 on number 1. And somehow it coordinates that. So this one with 300 pixels, that's 900 channels I need for 300 pixels because I need 3 per pixel. So it's obviously using universe 1 and part of universe 2. Rather than figuring out where that ends and where to start it here, I just go to another universe. And I say start this universe 3 for 300 pixels, and I know that's universes 3 and 4, 3 and part of 4. This is 5 and part of 6. This is 7 and part of 8. Okay. You also notice the light intensity here. RGB pixels, when you put 36 watts a reel on them, are really, really bright. The very first time I set this up, my neighbors all called me and said, "What are you trying to do? Give us a suntan here?" It was so bright, I couldn't figure for a few days where the setting was. And now they're super bright and they're only at 30% intensity. So I've actually modified the intensity here to dumb down the highest output of light so that they're not blinding everyone. So that's these outputs here. This particular board, if I go back to here, let me see if I can pull up the AlphaPix 4. Let me see. AlphaPix 4. Images. So there's the AlphaPix 4. I'm not sure that's what I have. That doesn't look like what I have. But we'll go with it. 4 outputs. I thought maybe an 8. Yeah, I'm not sure. Let's stick with that. So this is an AlphaPix with 4 outputs. It has 4 here. It has a chip here. It has a DMX output here. This one would go off to another DMX device like a dumb RGB controller. It has the Ethernet E1.31 connector here. It has the terminal for the power here. That actually might be the one I have actually. So in between each one of these, there's a fuse. And these, I can't remember if they're 15s or what they are, but it's good to buy those fuses. They're standard fuses. You don't have to buy them special from the vendor. They just charge you more money for them. So you can get them at a regular fuse place like a car store or something like that, auto parts store. So let me jump back to our controller. It's actually here. So each of these outputs correlates to 1, 2, 3, and 4. This output is the DMX output that goes on to another DMX device, so you can daisy chain in DMX devices, and that is controlled right here. What do you want that configuration to do? So I'm going to open another one. I'm going to open one of my other controllers here that I know happens to have, and let me jump back here, this setup. This is actually this one, where this controller is sitting there and then it has a daisy chain out to a dumb controller that this dumb controller doesn't actually have an Ethernet port to talk to. So you have to wire it DMX. So in this controller, this is the house one. You have your regular SPI outputs and whatever you program them with, but you have that other output, that extra output programmed, enabled, and I set it to a particular universe. So I mentioned this in the previous video, but what that makes this is that makes this output interface universe 99, and then mine has 4 regular outputs. So this is 99, and then I addressed everything on the RGB dumb controller with universe 99. And of course, if I've got 8 outputs, and this has 1, 2, 3, 4, 5, 6, 7, 8, 9 outputs. It has 9 outputs. It only needs 3 times 9 or 27 channels. And universe 99 has 512 channels, so there's plenty for the output of that controller. So that's how you control that. The Pixel protocol, if you recall this image where I went through the process of how the pixels work, let me just jump back here. This one. There's a chip in a pixel that handles the data for that pixel. And you have to know the protocol, because the way you put data on the line and the way it processes data is a little bit different. In the truest sense, the way it does it is it puts all the values on here, and this pulls the first 3 values off, which would be channel 1, 2, and 3. It takes them off and lets the remainder go down the line. So this pulls off the first 3 it gets, which would be channels 4, 5, and 6, and it lets the rest go down the line. And they're removing the data from the line as it goes down. So the protocol, and understanding the protocol, that chip is important. And you can see mine are the WS Pixel Protocol 2811, and there are some others there, but most of them are 2811. So you just got to be aware of what you're buying when you buy it. Again, we talked about the Pixel chip color order. There's a backlight control that is, I believe, the display on mine, the LCD. There's temperature settings here and voltage settings. So I can have particular temperatures. I can say when it gets too hot, 135 degrees Fahrenheit, shut the unit down. I have a trigger temperature of 100 degrees Fahrenheit of when to turn the fan on. And you can push firmware updates. You can see this is 2005. Lots of problems with firmware updates with this platform, the Alpha Pix. It isn't as smooth and easy as it always should be. But there's always a way to fix it. So I got on 2.02, and it seems to be pretty solid, so I'm not really messing with it because I don't really get a lot by upgrading this version to do more. Most of the functionality that you get to do is in the software, not in the controller. So that's the controller. In setting this up, what I'm actually getting is this. I'm getting this setup where I can actually have my software talk across the E131 to different controllers to address different universe numbers. And this is how the software is going to work. So having the controllers with the proper static IPs that don't change, so that when we go into the software lesson, you can tell them, at this IP address, I have these universes, and at these IP addresses, I have this universes. And the software is actually kind of cool. You'll see that in the next video, because that you can actually set up props so you can see what it's going to look like right on the computer display. I hope this helps you understand programming controllers within the DMX world, and I'll see you in the next video.